In this lesson, we will examine inverse trigonometric functions. Our objectives will be to review the definition of a function, as well as inverse functions, explore why domain is restricted for sine, cosine, and tangent in order to determine the inverse function, as well as to solve some basic inverse trigonometric functions for key values on the unit circle. Let's remember, a function must pass the vertical line test to be a function. A function must be one-to-one to have an inverse function. Therefore, it must pass the horizontal line test. And a function and its inverse are reflections of each other over the line y equals x. If we go back, you can see in the dotted or dashed line, that is y equals x. Here in red we have the function, and then you can see that the inverse is just a reflection of that function. If you'll notice our trig functions, these are all functions because they all pass the vertical line test. But we're going to examine why the inverse is not a function. If we look at this sine function, this is a demonstration from Wolfram, we can see that it would pass a vertical line test if I were to draw vertical lines. However, if I show the inverse of this function, you can see in red the inverse. If I were to draw a vertical line, it would intersect the function in more than one place, so it would not pass a vertical line test. Therefore, the inverse of the sine function is not actually a function. But we need to work with our inverse functions. So in order to do that, we can restrict the domain. So if I take the start of the domain, and you'll notice that in this example we're going from negative 2 pi to positive 2 pi. If I go ahead and I restrict this to pi over 2, so I have approximately negative pi over 2, and then if I restrict the domain to end to approximately pi over 2, you can see that in blue this would now pass a horizontal line test, and you can see that therefore our inverse now passes a vertical line test. So in order to have an inverse of our trig functions, we have to restrict the domain. We want to restrict the domain as close to 0 as possible. So this is how we restrict the sine function. Let's look at the cosine function. So if we start off, you can see that the cosine function is definitely not a function, or it is a function, but the inverse would not be a function. It is not a one-to-one function because it would not pass a horizontal line test. We can see that when we show the inverse of the cosine function in red, you can see that it does not pass a vertical line test. So we need to always ensure that our original function is one-to-one, meaning it will pass a horizontal line test, which will enable our inverse to pass the vertical line test. With the cosine, we also need to restrict the domain. With the cosine, we end up restricting the domain from approximately 0 to pi. And you'll notice that when we do this, now both functions are indeed functions, the inverse in red and the blue function that we have to start with. So the cosine has a domain restriction of between 0 and pi. Let's now go ahead and look at our tangent function. Is this function one-to-one? Would it pass a horizontal line test? Clearly that answer is no. Let's go ahead and look at the inverse. Look at all these red lines. That's the inverse of the tangent function. This definitely doesn't pass a vertical line test. So our original trig function is not one-to-one. Well, how do we restrict the domain with our tangent function? We restrict it to one interval here from negative pi over 2 to positive pi over 2. When we do that, we can see that our original trig function, our tangent function, is now one-to-one, which enables our inverse to pass the vertical line test. Let's go ahead and recap and review the domain restrictions. Our sine function, if you'll notice in red, is where we restrict our domain. And if you look at the unit circle, it's here in blue. We restrict it to pi over 2 and negative pi over 2. Notice that's quadrants 1 and 4. In quadrants 1, we will have positive sign values, and in quadrant 4, we would have negative sign values. So our sine function is restricted between negative pi over 2 and positive pi over 2. How about our cosine? Well, if we look at our cosine in red, we start at 0 and we go to pi. And here's a graphical representation. So our cosine goes from 0 to pi. In this case, quadrant 1 has our positive cosine values and quadrant 2 has our negative cosine values. Let's look at tangent. Tangent is the same as sine. We're going to restrict from negative pi over 2 to positive pi over 2. By doing that, we again have positive tangent values in quadrant 1 and negative tangent values in quadrant 4. Can you think about why that is? Well, remember, tangent is y over x, or sine over cosine. And in this case, sine is negative, while cosine is positive. You can see our tangent here. I went ahead and put the reciprocal functions in here so that you can see that they actually mirror their reciprocal functions. So the cosecant mirrors the sine as far as domain restriction, secant mirrors cosine, and our cotangent does in fact mirror our tangent. So keep this in mind when you're calculating to find inverse trigonometric functions. You'll notice when you start doing these on your calculator that your calculator automatically adjusts, because remember, if we don't restrict the domain, we don't have a function when we take the inverse. Let's try some examples. So first, what does it mean to find the inverse of a trig function? Well, here's one way you might see it. Inverse sine of 1/2 equals what? Or you may see it as arc sine 1/2. So how can we find that? What does that mean? What it means, since it's the inverse, is what angle of sine gives us an exact value of 1/2. So in both these different ways of writing this, that's what that means. What angle, if we take sine, will give us an exact value of 1/2. You should have these memorized. But remember, what quadrants are we looking in? We're looking in quadrants 1 or we're looking in quadrants 4. Since 1/2 is positive, we want to look in quadrant 1. 1/2. Well, if you'll notice right here, and we can remember that 30 degrees or pi over 6 gives us an exact value here of 1/2. So the answer to this inverse trig function is pi over 6. This will be helpful if you're actually solving problems where you're trying to find the angle, but you're given different lengths in a triangle. Go ahead and pause the video and see if you can determine the inverse trig functions for these exact values. Okay, let's look at the first one, the inverse sine of root 3 over 2. Or we could say arc sine of root 3 over 2. Either is acceptable. This is positive, so we know we're looking in quadrant 1. Well, root 3 over 2 we know is 60 degrees or pi over 3 radians. There's only one answer because we are restricting the domain. How about inverse cosine of -1? Well, remember that goes from 0 to pi. This is negative, so we know it's in quadrant 2, and cosine is -1 at pi radians. How about inverse sine of root 2 over 2? This is positive, so we need to look in quadrant 1, and we know that's going to be pi over 4 or 45 degrees. How about this one? -root 3. We're looking at the inverse tangent, so we know that this has to be in quadrant 4 because it's negative. So what value is this one? This is going to be a little trickier, but we can recognize that root 3 is either going to be 30 degrees or 60 degrees. So in other words, pi over 6 or pi over 3. So we can always try them. We know that it's y over x or sine over cosine. So let's go ahead and look at 30 degrees, or in other words, pi over 6. We know that the sine is 1/2 at that location, and the cosine is root 3 over 2. Canceling the denominators, we have 1 over root 3, which is the same thing if we rationalize as root 3 over 3. So that doesn't work. Let's try 60 degrees, and that would be pi over 3. Well, in this case, this is going to be reversed. So we will have root 3 over 2 divided by 1/2. The denominators cancel, and we get root 3. But remember, this isn't going to be pi over 3 because this is negative. So how do we write this? Well, when we think about our domain restriction on our unit circle, we are only in quadrant 1 or quadrant 4. We don't rotate through quadrants 2 or quadrants 3. So it either has to be a rotation up into quadrant 1 or a rotation down into quadrants 4. Since this is negative, then we know we need to rotate down. So our answer would end up being negative pi over 3. Be careful about that. When we have domain restrictions, especially with tangent or sine, we only rotate up from our initial side or down. How about this one, inverse sine of 0.8? Well, you're saying there is no exact value of 0.8 that I recognize. This is a situation where you can use your calculator. When you take out your calculator, you should have sine, cosine, and tangent, but you should also have the inverse functions, inverse sine, inverse cosine, and inverse tangent. Now, make sure that you put your calculator either in radian or degree mode. And you can tell because up in the screen of your calculator, it should say rad for radian if it's in radian mode. So if I want to know what the radian measure is of the inverse sine of 0.8, I would keep it in radian mode, and I would go ahead and type in inverse sine of 0.8, and I know that it would be 0.93. Now sometimes if you're working a word problem, that may not be convenient as far as understanding how big the angle is. So maybe we want to know what that is in degrees. In that case, I would hit inverse sine of 0.8, making sure to put my calculator in degree mode, and then I can see, oh, that's 53.13 degrees. So for certain values that we don't see on the unit circle or that we can't find, we can use our calculator to help us solve. And this concludes our lesson today on Introduction to Inverse Trig Functions. So at this point, you should be able to remember the definition of a function as well as how we get an inverse function. You should understand why the domain is now restricted for sine, cosine, and tangent. And you should be able to solve some basic inverse trig functions for key values on the unit circle.